a start button, and a pilot lamp. That is where most HMI tutorials stop, and it is a fine first screen. But it is not what a real operator stares at all shift. A real operator screen has analog gauges sweeping, live trend chart scrolling, and an alarm system you have to acknowledge and sometimes shelve when the plant goes sideways. That is the difference between a demo screen and a SCADA-grade HMI. This is PLC HMI simulation, the advanced version. We build all three, gauges, trends, and a full alarm system. It runs in a free browser HMI builder, bound to a live, simulated PLC. No install, no HMI license, no hardware. Quick recap of how the builder works, because everything here rides on it. You drag a widget onto the screen and bind it to a PLC tag. That tag can be an input bit, an output bit, a timer accumulator, a counter value, or an analog register. In run mode, that widget reflects the tag live on every scan. A pilot lamp bound to an output bit lights when the bit is true. That binding principle is the whole game, and it is exactly how Factory Talk View, WinCC, and Ignition work too. We already covered push buttons and lamps. Today we add the three widget families that make a screen feel like a real plant: gauges, trends, and alarms. Same builder, same binding, bigger widgets. Start with gauges. A push button is a 1 or a 0, but a tank level, a pressure, a temperature, those are analog. They live on a range. A radial gauge is how you show an analog value at a glance. You drop the gauge on the screen and bind it to an analog tag from the PLC, say, a tank level register. Then you set the engineering range, 0 to 100% or 0 to 10 bar, and the units. And here is the operator-friendly part. You add color bands. Green for the normal band, amber for high, red for critical. Now an operator does not have to read the number. The needle is in the green, the process is fine. The needle is creeping into the red, something is wrong. Bind it, and the needle sweeps live as the simulated value changes. That is your first SCADA grade widget. Next, trends. A gauge tells you where a value is right now. A trend tells you where it has been and where it is heading. A trend chart plots one or more tags against time and scrolls as new samples arrive. This is the same idea as the trend view control in WinCC or the trend object in Factory Talk View. Why operators live by it. The shape of a process tells you things a single number cannot. The slow ramp of a tank heating up. The sawtooth of a level controller filling and draining on a cycle. The sharp spike right before a fault trips. You add a trend widget and bind it to your level tag. Maybe add a second pin for temperature. Then watch the curve build in real time as the simulation runs. Seeing the sawtooth of a controller cycling is the moment trends click for most people. Now the centerpiece. Alarms. This is what separates a toy screen from a real HMI. You define alarm conditions, each bound to a PLC tag. A high temperature bit, a motor trip bit, a low level bit. And you assign each one a severity, how urgent it is. When that condition goes true, the alarm becomes active and pops onto an alarm banner across the screen, colored by severity, demanding attention. But active is only half of it. The operator has to acknowledge the alarm, to say, I have seen this, I am dealing with it. And the alarm tracks active and acknowledged as two separate states. Why separate? Because the condition can clear before anyone acknowledges it. The temperature drops back to normal on its own, and you still want a record that it happened, and that nobody looked. Active, acknowledged, cleared. 3 independent states. That is real alarm handling. One more state, and one standard worth naming. Shelving. Imagine a nuisance alarm, a flaky sensor that chatters in and out every few seconds. It floods the banner, so the operator cannot see the alarms that matter. Shelving lets the operator temporarily silence that one alarm on purpose with a record so the banner stays readable. Active, acknowledged, cleared, shelved, that life cycle is the heart of alarm management. And there's an actual standard for it called ISA-18.2. It exists for one plain reason, so that during a real plant upset, the alarm system helps the operator instead of burying them in noise. You do not need to memorize the standard. You just need to build screens that respect the life cycle. which is exactly what this builder has you do. Honest about cost. The HMI builder runs in your browser against a live, simulated PLC. No install, no HMI license, no hardware. The builder and the first exercises are free. You can drag on a gauge, find a trend, and wire up an alarm without paying. What the Pro upgrade adds is the full advanced exercise library, multi-screen SCADA-style projects, and the HMI designer certificate. That certificate is a portfolio credential. It is proof you have built and configured working operator screens with alarms and trends against a live simulation, something you can demo in an interview. So free to start and build real screens. Pro for the full path and the credential. So that is the jump from a basic screen to a SCADA Grade 1. Gauges with ranges and color bands, live scrolling trends, and a real alarm system with severity, acknowledge, and shelve. Build it free at plcsimulationsoftware.com/HMI-simulator. And when you want the structured route to the certificate, follow the guided stages. They're at plcsimulationsoftware.com/HMI-path. Links in the description. Next video binds the two halves together, a live ladder program and the operator screen that drives it in one browser tab. Subscribe. New video every Tuesday. See you in the next one.